So one of the things I love about teaching Math 10 is that it allows us to expand our knowledge so we're able to solve polynomials of higher degree. In the past, we've done linear equations and quadratic equations, but not very many equations where we had to really solve like degree 3 or higher equations. And so we're putting together these theorems that will help us do that. And one of the theorems we have, it's not really called a theorem, it's called Descartes' rule of signs, and it's named after the French mathematician René Descartes. And the rule goes like this. Well, let me tell you what the rule is for. It helps you know how many positive real solutions and how many negative real solutions you might have. So say you apply Descartes' rule of signs, and it turns out there are no possible negative real zeros. Then when you're doing your rational zeros theorem and you're figuring out, remember all those plus and minuses, well then if there aren't going to be any negative ones, you know not to try the negative ones. Okay, so it kind of helps guide you into your possible zeros. Okay? All right. So, and it goes like this. If we have a function, let's say, say we have this function, 3x squared, higher than that, let's make it 3x cubed minus 2x squared minus x plus 7. Let's say that's our polynomial function. Well, what we count is we count the sign changes. So if we want to know the possible positive real zeros, we're talking about the number of possible positive real zeros. You count the sign changes. Now, this is a positive, this is a negative, so that would be one sign change. This is negative, -2, but this coefficient is -1, so there's not a sign change. It's negative here and negative here. No sign change. But then it's negative here and positive here, so that's one sign change. So the number of possible positive real zeros is 2, or it could be 2 less than that. Could be 0. All right? But it couldn't be 1 or it couldn't be 3. So in your quest to find the zeros and you find one positive one, you know there has to be another positive one. Okay? So that's how that works. Now, we can also do it for negative. Number of possible negative real zeros. Well, what you do is you take f of negative x. So you're going to put in a negative x for all your x values. So 3 times negative x cubed minus 2 times negative x squared minus a negative x plus 7. And by the way, with Descartes' rule of signs, it has to be in standard form, but it does not have to have all the terms. You know how like sometimes you put in 0x when there's a missing term? You don't have to do that. So, all right, if I cube a negative, it's going to be negative. So that gives me negative 3x cubed. I have to simplify this. If I square a negative, that's going to be positive. So this part's positive. It's not going to change. Oh, I don't want the parentheses. It's not going to change the sign on that term. So I guess you could think of it as if it's got an even exponent, the sign's going to stay the same. If it's odd, it's going to change. Like here, it's got an odd exponent, so it's going to change to plus x. And then the plus 7 is going to stay plus 7. Okay, so from now we count the sign changes. We're negative, no sign change. We're negative, but now we're positive, one sign change. And then it's positive, no sign change. So there's one possible negative real zero. In fact, there has to be one, because you can't go 2 less than 1, right? Okay, so there is 1 possible negative real zero, and there's 2, or 0, possible positive real zeros. Okay, and I was only going to have 3 zeros at the most. All right, so it says use Descartes' rule of signs to determine the possible number of positive and negative real zeros. So let's do the positive ones first. So it's negative, no change. Negative, positive, 1 change. Positive, negative, change. Negative, negative, no change. So what I'm looking at is the coefficients. -1 to -3, no change. -3 to 6, change. It changed from negative to positive, right? Okay, and then +6 to -4, change. But -4 to a -12, no change. So there are 2 or 0 possible positive real zeros. Possible. I hate to keep writing it out. Positive real zeros. Okay, now we'll do the negative ones. So I take f of negative x is going to equal, now I have negative x to the 4th minus 3 negative x cubed plus 6 negative x squared minus 4 times negative x minus 12. Or you could just remember, hey, it changes the sign if it's an odd exponent on x, and it doesn't change it if it's even. So this is going to be negative x to the 4th. This is going to be plus 3x cubed. This is going to be plus 6x squared. This is going to be plus 4x, and then minus 12. So negative to positive, 1 sign change. Positive, positive, no sign change. Positive, positive, no sign change. Positive, negative, sign change. So possible negative real zeros. Looks like there's 2 or 0. Now you might be asking about, well, what about the zeros that aren't real, like if it had an I in it? We'll talk about that in another video.